Okay, there are three major factors in terms of the model. The model is the cause of behavior. The behavior here is forming solids, liquids, or gases. So we're going to talk about what causes something to form solids, liquids, or gases. Models in chemistry, the vast majority of the time, remember, deal with what the structural particles are doing. Atoms, ions, molecules. What are they doing? Their behavior is what the cause is what the model is. Okay? And sometimes it might be electrons, but most of the time in chemistry we're talking about the behavior of the structural particles here. Okay, there are three major factors that affect whether a substance is in one physical state or another. Can I ask one of your stupid questions? Answer it? Well, unless you're trying to be stupid, the only stupid question is the one you don't ask.
What's the difference between affect and effect?
Oh.
It's a new group. A lot of the emails are not going out, and I just
I never even saw that.
Okay. Don't worry about it. So I was looking in the box. Oh my God, all these dollars are sitting in the box. I'll come back before the end of the period to get those.
Okay. All right.
Thank you.
Sure. You know, I'd have to stop and think about that. Okay, that's kind of gets me off task here. You know.
Is that the right one?
Yep.
How do you know?
All right. Now this is the one you should already know. This is something you've discussed in a lot of science classes before you got to high school. You know that the faster the molecules or atoms move, the more likely it is to be a liquid, or the more likely it is to be a gas. Okay? I know you discussed this in physical science. I'm pretty sure it came up in earlier science classes, but I'd have to go back through the state standards to make sure. Okay? Now, in this class, we've discussed that temperature has to do with not just the speed of particles, structural particles. It also has to do with the size of the structural particles, and together speed and size are put together to have this property we call momentum. Okay? So in addition to the speed of the particles, it's the size, and it's also the shape. So we're going to put that in this circle over here. So it's how fast they're moving and how big they are that helps determine whether it's going to form a solid, liquid, or gas. The shape of that structural particle has an impact on this last circle over here. Okay, and the last circle is how sticky the molecules are to start with. Some molecules are very sticky, and some molecules or structural particles are not very sticky at all. Okay? If they're really, really sticky, you can get them to stick together even if the speed is high and the momentum is high. Okay? So stickiness. Now stickiness in reality has a better term, a more complete term, a more descriptive term in chemistry. We call it polarity. So it's the polarity that actually causes the stickiness. It's kind of like little magnets. The stronger the magnet, the more they want to stick together. Everybody got all this? You still writing? Now, if particles are structural particles are particularly large, particularly sticky, if you slow the particles down, they're going to be fairly easy to stick together and become a solid. Okay? If they're fairly small, maybe mostly round, don't have a lot of stickiness, it's going to be very easy for them to be a gas. So these factors are affecting then the boiling temperature and the freezing temperature. If it's easy to make it a solid, it has a high freezing temperature. If it's easy to make it a gas, it has a low boiling point. Okay?
So you're trying to say if it's a solid, then it's more stickier?
Not necessarily. It depends. All these factors affect whether it's going to be a solid. I'm just saying whether it's easy to be a solid or not. If it's easy to be a solid, then it's going to have a high melting point because you're going to have to put more energy into it to get it to be a liquid or gas. If it's not easy to get them to stick together, so they're little tiny particles, tiny structural particles, they're moving really, they don't have a lot of mass, they don't have a lot of stickiness. It's hard. It's easy to make them a gas, and you have to cool them down a long way before they even get to be a liquid. Okay, so they would have a really low boiling point. Okay, so all of these then, therefore, affect boiling and melting temperatures. boiling temperature is the same as the condensation temperature. Melting temperature is the same as freezing temperature. Melting temperature and freezing temperature are the same thing. Water freezes at 0 degrees C and it melts at 0 degrees C. Water boils at 100 degrees C and it condenses at 100 degrees C. And those are two values you need to know by memory. Okay? The boiling point and condensation point for water, 100 degrees C. At sea level anyway, average sea level pressure. Melting temperature, or I'm sorry, let's make it melting point and freezing point for water is 0 degrees C. You need to know those by memory.